opportunity for clinicians, scientists, and students to update the state of art in the field of spinal cord repair. Even more important is the way how the symposium was organized, including different perspectives, novel and controversial topics, and experience from different parts of the world.
So Giorgio, thank you very much. Thank you so much for this event. We can call the spirit of Brescia, like flying through the ocean of the knowledge.
This is a picture of rat spinal cords that have been cut sagittally, that is this way. And we took special care to stain both the bone and the spinal cord, and this is a very special stain, a very old stain. This is called Mallory trichrome.
And you see that genomic and personal genomics, I will go back to see what are we talking about. And so just give some introductory information that maybe all of you know, but I think is better to remind it since this is lecture.
A lot of the work over the last years has focused on spinal cord injury inflammation and inflammatory responses, and I would like to illustrate that in a little animation. Here you can see the spinal cord at 3 different levels, and we have some somatosensory trajectories going up towards the brain, where the emotional coloring of a sensory stimulus is performed, such as a pain stimulus, and we also have some motor command areas which are sending down signals down the spinal cord, innervating the muscle, and give us the ability to move around.
And the approach is to study regeneration, or neurodegeneration and regeneration, in many paradigms of neurodegenerative disorders and trauma, brain trauma, and even spinal cord injury.
But at the end of the road, we need to understand mechanism. And when we started our road about 30 years ago, and I'll take you through a quick marathon in 30 minutes on close to 40 years of work that is now encompassing pharma company, very rich drug market, and basic understanding of diseases. We didn't dream of diseases. We were curious scientists that were thinking of an unsolved problem in biology, but I think that this is another point of science, of the beauty of science, that you never know what's behind the corner, and what drives you should be just curiosity, not making money, not drugs, not diseases, but at the end of the road, if it is a good science, it will also doom to yield good results, and that's at least from our personal view.
But here I want to summarize all the different types of stem cells. Now there are several types of stem cells, and sometimes in the press there is a bit of confusion.
Glad cells, respectively astrocytes, and they are astrocytomas. According to World Health Organization, there are 4 degrees. The worst, the 3 and 4, are based malignant, aggressive astrocytomas, and with the potential to grow and spread impressively, and representing an unsolved problem by now.
Harvard University's Dr. Charles Shank said that the acupuncture system and stem cells are closely linked to an organizing center network composed of underdifferentiated electromagnetically sensitive cells.
But to date, there is a lot of way to do, and so the general audience may be cautious into very brief and general statement useful for clinical application.
What I see surprisingly here, that most of the speakers that came before me here stressed the view that probably the best results, the gain in the therapeutics field will benefit from the combination of different strategies, not stem cells alone.
And maybe we that these cells can do something to retard degeneration and eventually promote cell repair. And eventually, we can also think that this cell can control inflammation, as expected, for example, from cell therapy in multiple sclerosis.
The traditional approach to the spinal cord lesions has been to limit the secondary injury post-trauma, which is much easier than to repair the damage.
The lesion is a spinal cord cut to induce an initiation. We are going to do the same things with contusion, compression of the spinal cord too.
The first researcher on spinal cord injury was Gallenus in the 2nd century in Rome, but 18 centuries had to elapse before some other researcher took up new studies on SCI.
And the analysis showed that indeed in the renervated cells you have a loss of SAP97 signals. That means that the protein detaches from the receptors because the receptor is matured and is maintained at the level of the cell membrane, while the receptor, both GLUR1 and GLUR2 receptor, react with racing.
And the same is true, as you do know, from the proper spinal system, which you can heavily train, for example, in cats, which however works already different in other species, and we have only a very limited CPG-like activity so far seen in humans, and it's rather difficult to amplify this activity to a clinical